Hello, my name is Peter Mielecki. I'm representing the Shiny Pandas team. I will give you a brief overview of our solution to the optimization of soft mobility drop-off points case. In Porto, as probably everywhere else as well, some people just drop off their rented e-scooters at random locations. We like e-scooters because they help to overcome the so-called last mile problem. They contribute to a more sustainable city ecosystem, but we want them to be out of the way, please. We believe by optimizing e-scooter parking locations, we can somewhat remedy this problem. Let's look at the big picture. We have 216 parking spots in Porto. Here we indicate traffic on these spots by the circle radius. By zooming in, we can also see some more details. Differences can be quite big in terms of traffic volume. Red circle indicate parkings too close to each other. Only one of them can be kept according to the rules of this challenge. However, such GPS coordinate level data is quite hard to manipulate, so we decided to introduce spatial aggregation using Uber's H3 hexagonal grid system. This hexagonal aggregation now enables us to visualize e-scooters outside parking locations marked by gray color on this map. Basically, this map demonstrates quite well how much different parts of the city are affected by the problem of abandoned e-scooters. Our approach for finding optimal parking locations involves two main ideas. We define cost function that we want to minimize, and we apply a stepwise method of allocating parking spots at new locations. Our cost function aggregates the number of e-scooters multiplied by their distance from the nearest parking. Distance is measured in terms of steps on the hexagonal grid. In our stepwise allocation process, we pick those hexagons representing the highest cost contribution to our cost function and allocate parkings in them. Details are explained in our workbook. In short, our baseline cost of 42,000 went down to about 30,000 after 4 rounds of the above process. We consider this as a big improvement. As a result, we came up with a map visualization showing new recommended parking locations, proposals for removing unused parkings or parkings at less favorable locations. Of course, this system has its limitations. We could not take into account all the local regulations or practicalities that may influence the exact location of parkings. Thank you for your attention.